Hello everyone, welcome back to my YouTube channel. In today's video, we are going to discuss about Unit 5 of DBMS database management system, which is concurrency and control techniques. In this unit, we study about concurrency, what is concurrency, problems occur during this, and case study of Oracle and more. So let's begin. The first topic will be what is concurrency control in DBMS. So in DBMS database management system, concurrency control is a mechanism in DBMS that allows simultaneous execution of transactions while maintaining asset property, which we studied in previous video: atomicity, consistency, isolation, and durability. So basically, concurrency control is a mechanism in DBMS that allows execution of multiple transactions and maintaining the asset property. It maintains the integrity, accuracy, reliability of data when multiple users or processes perform read-write operations concurrently. All right. It helps manage issues like conflicting operations on shared data, inconsistent data states, lost or incorrect updates. So this is concurrency control in database management system. The next topic will be why we need concurrency control. So concurrency control is essential to prevent conflict between simultaneous transactions. It is necessary when multiple transactions will happen at the same time. Maintain data consistency and as well as accuracy in multiple user environment. Avoid problems such as dirty reads that I told you in previous video, what is lost update and inconsistent read. The next topic will be concurrency problems in DBMS. So when multiple transactions execute concurrently, several problems may occur. First will be dirty read, as we discussed in previous video as well. A transaction read uncommitted data from another transaction that may later roll back. And the next will be lost update, which is two transactions update the same data and one override the other. And inconsistent read, which is a transaction read the same data multiple times and the data changes in between reads. So this is concurrency problems occurs. Now concurrency control protocols, we have some protocols to control them. Concurrency control protocols defines rules to ensure correct and consistent execution of transactions. The main protocols are like log based protocols and timestamp based protocols. In log based protocols, we have simplistic, pre-claiming, two-phase and strict two-phase. And in timestamp based protocol, we have basic timestamp ordering, strict timestamp ordering, and Thomas Wright rules. So this is these are the protocols of concurrency control. The first protocol will be log based protocol, where we study about how the transaction will happen and read write operation how we allow. All right, so first one be shared log, which is denoted by S, allows a transaction to read only. Multiple transaction can hold a shared log on the same time. The next will be exclusive log, which is X, as we represent as X, and allows both read and write. Only one transaction can hold this log at a time. So this is the condition here. Two-phase locking is 2PL, which is phase 1, which is growing. Transaction acquires all logs but cannot release any. And the next phase will be shrinking, which is transaction releases logs but cannot acquire any new one. So these are the log based protocols in concurrency control. There is a note, which is this ensures serializability. I told you in previous video what is serializability. The next protocol, as we know, timestamp based protocol, where we study about every transaction is given a unique timestamp, like time of birth. So if a younger transaction tries to access data held by an older one in a conflicting way and the system rolls it back, this avoids deadlock entirely. So this is timestamp based protocol of concurrency control. The next protocol will be validation based protocol in DBMS. So let's talk about what is this. Validation based protocol, also known as optimistic concurrency control. It is a technique in DBMS used to manage concurrent transaction without locking data during execution. In previous protocols, we study about locking protocols. All right, and this protocol is basically used to manage concurrent transactions without locking data at the time of execution, and it assumes that conflict between transactions are rare and delay conflict detection until the validation phase just before committing. So this is validation based protocol. The phases of validation based protocol are: the first phase will be read phase. There are three phases. So the first phase will be read phase. The transaction read the data and perform calculation using temporary variables. Alright, so in read phase, only only we read the transaction data, and the calculation performs in temporary variables or using temporary variables. No changes are made to the database yet. In read phase, database not be updated. All right, and the next phase will be validation phase. In this, before committing the transaction, check for conflict with other concurrently running transaction. If no conflict is found or serializability is preserved, it proceeds to the right phase. So this is validation phase. If validation fails, the transaction is aborted and restarted. The last phase of validation phase is write phase. If validation passes, the transaction write changes to the database, and in this phase, the transaction is updated finally. If validation fails, the transaction is aborted and may be restarted, and these all are the phases. The next topic will be multiple granularity, which is locking the entire database for one small change in efficient. Locking every single row is too complex. So this is multiple granularity, where we study about granularity. What is granularity? Granularity refers to the size of data item on which a lock is applied. So it is basically a size of data where lock is applied. And multiple granularity locking introduce a hierarchical structure where locks can be applied at various levels, like example database file record, to balance efficiency and concurrency. So in this we talk about locking the data or size of data where we apply lock, and here is hierarchical structure where multiple levels are there. So for example, granularity hierarchy is a typical hierarchy can be visualized as a tree, like we have database where area, file and records are there. The next topic in this will be, like in multiple granularity, we have intention mode lock, which is to support hierarchical locking. New intention lock mode are introduced alongside share S and exclusive X, as we discussed earlier. Intention shared will be explicit locking at a lower level of the tree, but only with shared locks, and intention exclusive, where explicit locking at a lower level with exclusive or shared locks. At last, shared and intensive locking will be the subtree routed by the node is locked explicitly in shared mode, and explicit locking is being done at lower level with exclusive mode locking. So in this, both will be covered. So this is intention mode locking. The next topic will be deadlock handling. This topic we also study in operating system. So if you studied there, then you don't have to study here. Alright. So a deadlock occurs in a multiple user database environment when two or more transactions block each other indefinitely by each holding a resource the other needs. This result in a cycle of dependencies like circular wait where no transaction can proceed. We have deadlock detection. The topic inside deadlock handling will be deadlock detection. So this comes in a single question, like what is deadlock handling, what is deadlock detection, and explain prevention as well. So this comes in 7 marks. So what is deadlock detection? If a transaction waits too long and the dbms checks if it parts of deadlock, then we have method like wait for graph, nodes transaction and edge will be waiting relationship. If there is a cycle, a deadlock exists, and it mostly suitable for small to medium databases. What is deadlock prevention? So for a large database, the deadlock prevention method is suitable, and a deadlock can be prevented if the resources are allocated in such a way that deadlock never occurs. Alright, the DBMS analyze the operations whether they can create a deadlock situation or not. If they do, the transaction is never allowed to be executed. So we prevent them with the mutual exclusive as we study there. So if you want to study more about this, then you can refer operating system unit. All right. The next will be deadlock prevention mechanism purposes to schemes like wait die scheme, non-preemptive. Older transactions are allowed to wait and younger transactions are killed. So this comes in the same. All right. When we write about deadlock prevention, we have to consider these two schemes also to make complete answer. All right. So, request a resource held by an older one. For example, we have considering two transactions like T1 is equals to 2 and T2 is equals to 20. If T1 is older, want a resource held by T2, so T1 has to wait. And if T2 younger wants a resource held by T1, so dies and restart prevent deadlock by not allowing a younger transaction to wait and form a wait cycle. So this is the first scheme. The next will be bound wait scheme, which is preemptive. Older transactions are aggressive and can force younger ones to abort, and younger transactions must wait if they want a resource held by an older one. So for example, consider two transactions T1 and T2 as we consider in previous example, and if T1 is older wants a resource held by T2 is killed and T1 is proceeds, and if T2 younger want a resource held by T1, then it will wait for that. The next topic will be recovery system and log based recovery. So it refers to the final state of a transaction. As we know, this is the final state where indicating that it has completed its execution. Once the transaction reaches this state, it has either been successfully committed or aborted. In this state, no further action are required from the transaction as the data is now stable. So this is the recovery system. In Logbase, the logs are there, a file containing every change made, and deferred updates like changes are recorded in the log first and only applied to the actual database after transaction commits. In immediate update, changes are applied to the database as they happen. If a crash occurs, the system uses the log to undo uncommitted changes. When we talk about checkpoints, periodic makers, where the system ensures all log records are physically written to the disk, and this speed up recovery after a crash. So this is log based recovery. The last topic of this unit, which is Oracle case study. Let's talk about what is Oracle. So as we know, Oracle is a database. Here we talk about introduction. So Oracle is a relational database management system like RDBMS. It is designed for grid computing, like meaning it contain uh, or it can handle massive amount of data and thousands of users across multiple servers. All right. So feature of Oracle will be it is multi-platform, like run on any type, Windows, Linux, Unix, everywhere. And the targeted audience of Oracle will be large expertise like bank, airline, e-commerce sites that cannot afford 1 second of downtown. Where we does not afford 1 second of downtown, we use Oracle database there. Let's talk about Oracle logical versus physical structure. When we talk about logical structure, how the database looks to the user. Like table spaces, the largest logical unit, segment, space allocated for a specific object, extends a specific number of contiguous data blocks, and data blocks means the smallest unit of storage in Oracle. When we talk about physical structure, the actual files on the hard drive, data files are like store the actual data of tables or indexes, and in control files store the metadata like database name, timestamp of creation, and redo log file where records every change like made to database used for recovery. So this is Oracle logical and physical structure. The next will be Oracle concurrency control like MVCC. So Oracle uses multi-version concurrency control. So this is also important. How or what type of concurrency control Oracle uses. So multi-version concurrency control Oracle uses, and the problem will be in many databases. If user A is updating a row, user B cannot read it until the update is finished. So the solution provided by Oracle will be readers never wait for writers. When user A start updating, Oracle creates a snapshot of the old data in undo segment. So it helps in managing multiple users at the same time. All right, like the next user will not have to wait for the first user to if he start writing, then the next person will be uh, start reading, and Oracle create snapshot for them, and user B can read that old snapshot while user A is busy. So this makes Oracle incredibly fast for high traffic apps. So where we use Oracle, where we does not have 1 second downtime. All right, the last will be Oracle instance what was versus database. So the database, like the physical files on the disk, the book, and the instance will be the background processes and memory, like SGA, the read those files, the reader. The SGA will be system global area, that means the memory area that stores the data buffer cache, and SQL code for fast access. So all these are the case study of Oracle. That's all in this video. Thank you so much.